Hello everyone, my name is Satya. Welcome to my video today, which speaks about introduction to TCP/IP with respect to wireshark tracing. Right. So let me explain what exactly we did in our last class. We discussed about TCP/IP protocol stack. What is IP address? What is net mask? Or subnet mask, what is default gateway, and other things we discussed, right? So I will put the video link in the description box for the first video, so you can go through it and then come to this video as a extension of the previous class, right? So I also use the term called as wireshark. Wireshark is a tool that is used to capture the packets on the wire or in the wireless medium, right? So it will only capture the packets with respect to TCP/IP protocol stack, right? So in today's class, I will show you what exactly this wireshark tracing does and how we can study the TCP/IP stack with respect to each layer in the packet that we capture, right? So let's not dwell too much into the previous video aspects. Let's go on to what we need to discuss as part of today's video, right? I'll switch my camera. So as you see here, this is the wireshark tool. As part of this tool, I have already started this tool and captured the packet, right? So let me switch the screen to the command prompt. Here, as you see, I've run certain script, then I run ipconfig and I have pinged to google.com, right? So as part of different tools that Windows provides, ping is one tool. Ping is a application or a program that will tell you whether you are able to reach a particular destination successfully or not. So google.com is our web server, right? That we usually use to search for different information in the internet, right? So I just do ping space google.com as it is. I am not using any IP address here. So automatically what happens is when you do the ping, the first packet to google.com, I will switch to the Wireshark. It will send a DNS packet, right? So DNS I discussed in the last class itself. It is called as domain name server, right? So our domain name server is represented by an IPv6 address, which is our broadband gateway, right? So you may ask me why the DNS server is not reached through IPv4. Usually, what is the technology that is evolving in today's world is, if given a chance, if IPv6 address or IPv6 technology can be used for communication, then IPv6 addresses are used for communication. If IPv6 communication is not possible, then we go back to the IPv4 backbone or IPv4 packets to communicate to broadband gateway or to the internet. So here our DNS packet that is used to resolve the address google.com, right? The URL I should say, is resolved using the DNS server, which is this one, fe80:22b8:2bff:_fe13:2c22. So this is the DNS server or DNS application residing on the broadband gateway that I have at my home, right? So as you see here, it's a standard query which says standard query and it is of type A. There are two types of record types. One is A and one is quad A, right? 4 times A. If it is A, then the whatever resolution resolved IP address is IPv4 address. If it is quad A or 4As, then the resolved IP address for google.com will be an IPv6 address. So as you see here, the response for the first one, google.com, is 142.251.39.110. Just remember this IP address. And for quad A, it is an IPv6 address 2A00.145.0.400E 803.200E, right? So now I'll switch the screen again to go to the ping response. As you see here, 142.251.168.139. Is this the same IP address that we got from google.com? No, this is not the same one. So what we need to do is, now we need to check what is the response in domain name system, right? So this is the query. Yeah, so we need to check for the response. The answers are here. Okay, so let's go back to the okay. So this is another technology wherein even though we are sending, we'll check another packet which is called as ICMP, which is a protocol used to send ping packets. So once we get our IP address resolved, right? So now we need to check how is the packet being constructed, or a ping packet being constructed. So that we can check using ICMP. So as you see here, I'm putting a filter. First I put a filter as DNS. Now I'm putting a filter as ICMP. So as you see here, from our IP address. So if you check my script ipconfig.py or ipconfig on the command prompt, you will see that the IP address of my system is 192.168.129.14, and the packet that we are sending the ping packet to 142.240 and 168.139, that matches with the address that we got from DNS. So let's quickly go back to the DNS. I put the filter as DNS, domain name system. Then the response is this one. So we are sending a packet to ICMP packet to 142.251.168.139. Okay. So here you can see that ICMP packet, the TCP/IP stack is constructed here. The application layer protocol is Internet Control Message Protocol, which is used to construct and send a ping packet with a certain payload to the google.com server. So it gives, but Internet Control Message Protocol does not use a transport layer. It directly sends the packet to the Internet Protocol stack. Here Internet Protocol says the source address is 192.168.129.14. Destination address is that address that we got from DNS server, 142.251.168.139, and we send the packet to that. And as you know that if the address is other than, I will go back to the previous screen, which is command prompt. Here I've already run my script. I say my network ID is 192.168.128.0 and my default gateway is 192.168.128.1, right? So the network ID is 192.168.128.0 and the address that we are trying to ping, which is of Google server, is 142, right? So if you go back to the wireshark, 142.251.168.139, which is completely different network ID. So now what we have to do, we have to send the packet to the default gateway, which is 192.168.128.1, right? 128.1. Now what is the MAC address, right? So if you check here, the Internet Control Message Protocol, it's sending it to my Broadcom box, which is my default gateway, 192.168.128.1. 128.1. So this is the MAC address. So if you put here a filter as ARP, see here, who has 192.168.129.14, tell 192.168.128.1. Now this is the ARP resolution packet that is sent from the broadband box that I have installed in my house. So he sends who has my IP address 192.168.129.14, which is my laptop IP address. Tell the broadband gateway, which is 192.168.128.1. Then my laptop says that laptop is my the home laptop that I'm using. He sends a ARP response saying that 192.168.129.14 is at this address, right? Once you send this address, the broadband gateway updates the 192.168.119.14 is at that particular MAC address, right? But once you receive the packet or packet which says who has 192.168.129.14, tell 192.168.128.1, the my home laptop records the MAC address of the broadband gateway, which is this one, 20B8 2B13 2C22, right? Now if I put back ICMP again here, there will be 4 ICMP packets since Windows sent 4. See here, there are 4 ICMP packets. And if you go to the MAC 20B8 2B13 2C22, this is the default gateway IP address. So any packet which is sent to a destination address which does not match the network ID of the broadband gateway, then it will be sent to the default gateway, that is the broadband gateway. Broadband gateway will forward the packet outside to the network, right? Then it has to NAT 192.168.129.14 will be translated or NATed into a public IP address, and then it will be sent to the internet. So this is the private IP address. So here you see Internet Control Message Protocol, ping is an application layer, Internet Protocol version is transport layer protocol, Ethernet is MAC layer protocol, and this is the frame. So on the frame, right? So you see 74 bytes are on the wire. So here our wire is a Wi-Fi medium because my laptop communicates with the broadband gateway using Wi-Fi medium. So that's how it is sending the packets to the internet. Okay. So this is how it looks like. Now let's go back to the DNS packet to discuss about the transport layer also. Now this is the packet that we sent. Standard query, where is the google.com? Yeah, there it is. So here, this packet which says I put the filter as DNS, domain names server, domain name system. I am talking about the queries. So query is, the DNS protocol works on query response mechanism. So we send a DNS query to a DNS server. It responds with a response saying that the IP address for a particular URL is this, and that is the response. So here you see here clearly domain name system is application layer, and on top of it is transport layer. The source port is, I told you in the previous video, can be anything 51,580, and destination port is always designated port for a particular application. For domain name system, the destination port is 53. Then the internet protocol, right? It says internet protocol version 6. Here we are using link local address. This is my link local address of the system, and this is the link local address of the broadband gateway. So now if I go back to my program that I have written to automate the network, here it says pinging FE80:1F41:A537 4F95. So this will be the address that will be used by the wireshark 4f95. As you see here clearly, the end hexadecimal tuple is 4f95, and it is sending to a destination address which is the broadband gateway where DNS server is residing. So it will have the address with the last hexadecimal tuple as 2c22, and this is the query, and as we discussed, the response is here. Okay, so now this is how the TCP/IP stack is defined. To just revise what we discussed in this class, we discussed ping protocol, ICMP, internet control message protocol. There we don't use the transport layer protocol. It directly sends the packet to the internet layer, then to the MAC layer, and then to the Wi-Fi medium. The domain name system is application layer. UDP is the user datagram protocol, which is the transport layer. Source port is anything random from 1 to 65,536. Destination port is designated for domain name system is 53, and then it gives it to internet protocol. It puts an IPv6 address or IPv4 address, whichever IP technology that we are using, IP version 4 or IP version 6 it will use, and then Ethernet will put the MAC address, which is my laptop MAC address is this one, and as you know, the broadband gateway is ending with 2c22, and it will send it to the broadband gateway DNS server, right? And it will be sent on the wire, which is 90 bytes, and the wire is Wi-Fi medium. Now you might ask me, before we close this session, that why we don't see the Wi-Fi layer statistics. Now, for capturing the packets at the Wi-Fi layer, we need a separate capturing device or a tool that will capture the packets on the Wi-Fi. Otherwise, you won't see the packets at the Wi-Fi layer, right? It will only show the TCP/IP stack packet structure, right? So how the packet is constructed with respect to TCP/IP. So the Wi-Fi medium or the wireless LAN medium headers will not be shown as part of this. We need a special tool for it. Okay, friends. So this is with respect to analyzing wireshark trace for TCP/IP. We'll discuss in the next class in more detail how we automate this wireshark tracing using T-Shark or other tools, right? Thank you for attending this class. Bye.